Hi, this is Mary. I am here once again to give you one more fruitful knowledge in algebra. In our episode last week, which is sequence, we compute for the n terms of finite and infinite sequence based on the given. Let's have a recap on sequence by giving examples. Find the range of values of the sequence given by a sub n is equal to 5n minus 2 for the domain 1, 2, 3, 4, and 5. For n is equal to 1, a sub 1 is equal to 5 times 1 minus 2, which is equal to 3. When n is equal to 2, a sub 2 is equal to 5 times 2 minus 2, which is equal to 8. A sub 3 is equal to 5 times 3 minus 2, which is equal to 13. When n is equal to 4, a sub 4 is equal to 5 times 4 minus 2, which is equal to 18. When n is equal to 5, a sub 5 is equal to 5 times 5 minus 2, which is equal to 23. The sequence are 3, 8, 13, 18, and 23. Let's have another example. Given a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, ellipses, up to a sub n ellipses, find the 15th term of a sub n, which is equal to 2 raised to n minus 2 minus 5. For the value of n, which is equal to 15, a sub 15 is equal to 2 raised to 15 minus 2 minus 5, which is equal to 8,187. Let's review the answer for our first example. We have sequence 3, 8, 13, 18, 23, and a sub 1, a sub 2, a sub 3, a sub 5 ellipses, a sub n ellipses, wherein the 15th term is 8,187. When we add the terms in the sequence, we will have what we call series. Series is the sum of n terms in the sequence. The series obtained by adding 6 terms of the sequence 3, 8, 13, 18, 23, which is 3 plus 8 plus 13 plus 18 plus 23, which is equal to 65, which is also called as finite series. The sum that we have get in the finite series is partial sum. It is denoted as S sub n. So in our previous example, S sub n is equal to 65. Moreover, the sum 1 plus 3 plus 9 plus 27 plus 81 plus ellipses continues indefinitely and is called an infinite series. Then, it is finite series when we add terms indefinitely, and infinite series when we add terms with ellipses at the end. We have finite series, infinite series, and I will introduce another kind of series, which is the harmonic series. What is this harmonic series? Harmonic series is the infinite sum of the reciprocals of positive integers. Example, 1 plus 1 half plus 1 third plus ellipses plus 1 over r plus ellipses. As you can see, our variable r is in the denominator. All in all, we have 3 kinds of series: finite series, infinite series, and harmonic series. Let's distinguish what kind of series are these examples. The first given is 1, 3, 5, 7, 9. The second given is 5, 10, 15, 20, ellipses, 5r, ellipses. The third given is 1, 1 half, 1 third, plus ellipses, plus 1 over p, plus ellipses. The first example is 1, 3, 5, 7, 9 is an example of a finite series because there is a definite number of terms in the sequence. The second example, 5, 10, 15, 20, ellipses, 5R, ellipses, is an example of infinite series because there is infinitely number of terms in the sequence. In the third example, 1, 1 half, 1 third plus ellipses plus 1 over p plus ellipses is an example of harmonic series because there is an infinite sum of the reciprocal of all positive numbers. Series can be represented using the sigma notation. I have a separate episode about sigma notation if you want to go deeper about sigma notation. Let's have an example. Last time, I had told you to determine what kind of series is the example, and one of the given is 5, 10, 15, 20, ellipses, 5R, ellipses, which is an infinite series. Let us express this in a sigma notation. Since we're going to get the value of 5R in the given terms, we will come up to this notation. As you can see, in the summation notation, we have the digit 10 on the upper, which is what we call the largest value that R can take. And on the lower level, the R, which is equal to 1, signifies the smallest value that R can take. This is read as the sum of 5R from R is equal to 1 to R is equal to 10. So what is the answer for the given? When n or when R is equal to 1, 5 times 1, which is equal to 5. When R is equal to 2, 5 times 2, which is equal to 10. When R is equal to 3, 5 times 3, which is equal to 15. When R is equal to 10, 5 times 10, which is equal to 50. So you're going to get the value of 5R from 1 up to 10. Sometimes you will also have to interpret a sum given in sigma notation and expand it into individual terms. For example, let's find out the sum of 3R plus 1 for R is equal to 0 to R is equal to 4. For R is equal to 0, 3 times 0 plus 1, which is equal to 1. For R is equal to 1, 3 times 1 plus 1, which is equal to 4. For R is equal to 2, 3 times 2 plus 1, which is equal to 7. For R is equal to 3, 3 times 3 plus 1, which is equal to 10. For R is equal to 4, 3 times 4 plus 1, which is equal to 13. So 1 plus 4 plus 7 plus 10 plus 13 is equal to 35. Let us answer this. For each of the following series written in the sigma notation, write the first 5 terms. In the first given, we're going to find the sum of R times R minus 1 from R is equal to 1 to R is equal to 5. For R is equal to 1, 1 times 1 minus 1, which is 1 times 0, is equal to 0. For R is equal to 2, 2 times 2 minus 1, which is 2 times 1, which is equal to 2. For R is equal to 3, 3 times 3 minus 1, which is 3 times 2, which is equal to 6. When r is equal to 4, 4 times 4 minus 1, which is 4 times 3, which is 12. When r is equal to 5, 5 times 5 minus 1, which is 5 times 4, which is equal to 20. The sum is 0 plus 2 plus 6 plus 12 plus 20, which is equal to 40. In our second example, we were going to find the sum of negative 1 raised to r times r squared from r is equal to 1 to infinity. So as you can see, there is an infinite symbols there, means it is infinite number of sequence or infinite terms in a sequence. For r is equal to 1, negative 1 raised to 1 times 1 raised to 2, which is negative 1 times 1, which is equal to 1. For r is equal to 2, negative 1 raised to 2 times 2 raised to 2, which is equal to 1 times 4, which is equal to 4. When r is equal to 3, negative 1 raised to 3 times 3 raised to 2, which is equal to negative 1 times 9, which is negative 9. For r is equal to 4, negative 1 raised to 4 times 4 raised to 2, which is 1 times 16, which is equal to 16. When r is equal to 5, negative 5 raised to 5 times 5 raised to 2, which is equal to negative 1 times 25, which is equal to negative 25. So the sum is 1 plus 4 minus 9 plus 16 minus 25 plus ellipses. I hope you like this video. If you haven't subscribed to my channel, don't forget to watch all of my videos and also like, share, subscribe, and click the notification bell down below. See you next week.